right, so my talk is a little bit different to a lot of the talks today. My talk is going to involve a little bit of mathematics, which is nice, I think. And also, it's not going to talk about online teaching because I've done online teaching for 13 or 14 years. So, you know, just bear with me if this is not what you expected today, but I hope you enjoy it anyway. The basic idea of my presentation is encouraging students to look before they jump into solution strategies or problem-solving techniques. And I'm going to look at some simple mathematical inequalities. And so you can all play along at home or in the office. They're not very demanding, but they are the type of inequalities that you see in senior high school in New South Wales, so in the HSC, and probably first year mathematics. So I'm Chris Tisdell, I'm a professor at UNSW. Jan Roberts is a new PhD student of ours, and Laura is a postdoc. She works in mathematics education. Okay, so what do I mean by learning to look? Well, I'm glad you asked. Let me give you a little problem here. Okay. All right. So this is a problem that you see in primary school, actually. And of course, you would know the answer to this is just 365. But some students still look at the numerator and they add up these numbers and they divide it all by 3, right? Why? Because they didn't look. They didn't look. They just know a technique and they just go straight for it. What about this one? I'm sure you'll all identify with this one. 14 minus 9. Okay, well, it's a column arithmetic. Well, of course. Oh, 4 minus 9, 14, 1, 14 minus 9, 5. Again, it's a bit crazy because you don't need to do that for a problem like this, and you don't need to add up the numerator and divide by 3. So that's what I mean by learning to look, okay? All right, so what about the inequalities? Well, let's get on to some more serious mathematics here. Inequalities, you see them in places like HSC exams and in first year in maths. It might be something like this, right? 1 on x minus 1 is greater than 3 or something, and you're asking the students to solve it for x. Okay. Now, most of the ideas and the problem-solving techniques that I think we teach involve algebraic manipulation and maybe some graphing techniques. Okay, like so think about how you might solve this. But, and I'm going to be a bit provocative here, have we become too comfortable? Well, I think we have, and in particular, I think we are over-reliant on one-size-fits-all ways of thinking and working and teaching. And so I'm going to offer you some alternatives today. Now, you might have seen them before. This is the second time that I've given this talk. Nobody's sort of jumped in and said, oh, I've seen this. This is not new. But even if you've seen it before, I think it's hopefully enjoyable. All right, so I'm going to respond and offer some alternatives, okay? And in particular, when it comes down to inequalities, you probably know this, this idea here. Okay, the transitive property of inequalities. Okay, so this works with inequalities, with equalities, with all sorts of things. So actually, let me just put that in there and we can fix that up. It has nice applications. You know, if Volker's taller than John and John is taller than Mary, then Volker's taller than Mary, right? We all know these sort of transitive properties. Okay, so this is what I'm going to work on. And I had a look at some of the textbooks that you see in senior high school and early first year university. There are very few problems on the transitive property. And I think that sends a very dangerous message to learners, because if there's no problems and there's no assessment, it means we're actually not really valuing it. So let me show you what I mean. Okay. Now this is, I'm sort of having a go at my own university at the moment. So, you know, we're not perfect either. This is from a set of first year notes, right? And you're supposed to solve this inequality. Okay. Now here's something that I think is a slightly concerning. This is the narrative from the explanation of this example. To solve the inequality, we cannot simply multiply the inequality through by x minus 1, since we do not know whether x minus 1 is positive or negative, and taking the reciprocal of both sides is problematic. This is wrong. This is wrong. Why? Because this is bigger than that, that's bigger than 0, therefore, by the transitive property, like I can see what they're trying to say there. You can't do this in general, but this is obscuring what's going on with this simple example, right? So obviously this then implies that x minus 1 is greater than 0. Okay, so that's just not true. If this was a negative 1/3, okay, no problem. I get that. And so it got me thinking, we've got these general techniques, right? And what one technique is, you multiply by the square of the reciprocal, you know? But to me, that's like using a sledgehammer to crack a nut. You're using these giant techniques, these heavy machinery, to solve something that you can do in maybe 1 line, 2 lines. You know, x is greater than 1, multiply it by x minus 1 and rearrange it. Okay, so the suggested solution is to multiply by the square of the reciprocal. And then you get a quadratic inequality, and then you rearrange it, factor it. I think you draw a graph, right? 1 and 4, and this is your solution. Oh, sorry, yes, that's correct. It's where it's negative. Okay, so that's your solution. So we had to do quite a lot to actually get there. So what about the transitive property? Well, again, 1 on x minus 1 is greater than that. So that's that. So multiply both sides by x minus 1, right? So you get the same, right? You rearrange that. X is less than 4. Okay, so you know that x is greater than 1, x is less than 4. You combine them, and there you go. So we didn't, let me get my sheet. We didn't have to draw a picture. Oh, there it is. We didn't have to work with a quadratic. We didn't have to factorize anything. Come on, right? So I think I can see why this is good, because you can't do this in general. But why are we giving them problems that and a narrative that really just doesn't fit together? So here's another example. Stewart, you might know James Stewart, right? He got very famous and very rich by writing big calculus textbooks. I got to meet him a few times, and he was a great guy. But let's look at an example from Stewart's book. So you're asked to solve the following problem, and then Stewart gives a warning to learners, right? It is tempting to simply multiply both sides of the inequality by x. Okay, that should be a by x. As if this was an equation, but this doesn't work because we don't know whether x is positive or negative. So we can't tell whether the inequality needs to be reversed. Now, you can probably tell what I'm going to do, right? Well, so 3 on x. Of course we can tell, James. Okay. The reason we couldn't tell is because we didn't look. We didn't look, James. Okay. So I can see the point, but to me, you're using a sledgehammer to crack a little nut. Okay. So how does Stewart do it? Well, bring the 1 to the other side and put it over the same numerator, and then you form a table, right? You look at the zeros of the numerator and the denominator, and you form a table, and you put in different values. Okay, it's quite a long process. So again, pause, look, use the transitive property, grab that, and then it's actually contrary to Stuart's position. We do know the sign because we stopped to look at it. We can multiply both sides of x. Okay, so when you multiply both sides by x, you get x is less than 3. So, x is greater than 0, x is less than 3. That's it. Okay. So here's my last example, because I want to get everyone back on time. I went through lots of old HSC exams, right? Here's another example. Okay, this one's a little bit different. But again, you can probably see what's going to happen. Well, 1's greater than 0, so this has got to be greater than 0. The numerator is positive, so the denominator's got to be positive. So we know that x is 0. Now, I've had colleagues who have criticized students for a problem like this, and they've taken off marks because the students have multiplied by x minus 1. Now, maybe they haven't justified it by saying that this is positive, and that's obviously a problem. But we're so deep in these methods that we don't actually stop to think about what we're doing. So I'm going to stop sharing.